So today we're going to learn this thing called chapter 6. Chapter 6 is the most important chapter because you're going to cover it a lot in the future chapter, which is form 5 right now, right? So what you're going to learn is acid alkali base formula, the salt, and also the calculation. This will be like very important actually. This will be one of the most important one. This also one of the most important one. This also one of the most important one, right? But later you're gonna see I put star next to it. Star, just don't worry, star doesn't signify the difficulty, it signifies the importance. Okay. So you have to, of course, prioritize the star. So now the first thing that we're gonna learn is the acid and base formula. So we already know all of this formula, right? I'm just making you sure that you remember all of this. So the main key point here, right, for the acid formula, right, you have to know all of this formula and then what is the product of it. Okay, product. First of all, you understand, right, what is the reactive formula? Reactive formula is reactive metal. I mean, reactive metal, right? You have to look at the ECS series. What is the ECS series? ECS series, right? ECS series, right? It's actually a electrochemical series, right? Which is like a series which shows the electropositivity of a certain item. For example, right? This is the way I remember the series, right? Kalau nak kahwin, mesti ada zakar fantastik. Sebab, sebab papa hendak cucu anak. This is the way I remember. And what does this tell us? This tell us the electropositivity of a certain things. The tendency of an element, right, to donate electron. Okay, that is electropositivity. Okay, so the more higher it goes, the more it likes to throw away the electron. Basically, right. So basically, you have to understand, right, reactive metal comes from ECS series. Okay, and what is reactive, what is not reactive? Anything higher than hydrogen. Okay, so copper and argentum, right, is not reactive. Okay, is not reactive. So for example, if you were to see this formula, right, okay, let me write the formula. If you were to see HCl plus, I don't know, let's see, copper, right, copper, it should produce a CuCl2, right, and also water lah, right? But this is impossible. You know why? Because copper is not reactive. It is not reactive. So the formula won't actually produce anything. Okay, so this is impossible. Now the second formula, acid plus carbonate metal. Carbonate metal is anything with CO3. Okay, and just in case you forgot lah, right? Carbonate metal, right? They always like to call them, right? Okay, if you ever see in a question, right, in a question they say something like plus limestone plus something something, right? Limestone, right? If you hear limestone, just know they never give you the formula. You have to understand first. The formula is actually CaCO3, calcium carbonate. That is limestone. Don't forget this formula. This formula they like to ask in SPM actually. They like to ask like something something with limestone. They don't tell what is limestone, but you have to understand limestone is CaCO3. Okay, but of course this is not talking about CaCO3. We are talking about any metal with carbonate, right? So it produces salt, CO2 and hydrogen, water. Sorry, water. Okay, acid plus base or alkali equals salt and water. This reaction is called neutralization, lah, right? Neutralization. Let's see here. Yeah, okay. I thought I don't know how to spell it, but yeah, this is how you spell it. Neutralization, meaning you are neutralizing a pH level. For example, this will be a pH, lah, right? This will be a H plus, lah, right? And it will be OH minus, lah, right? You are neutralizing it, so it becomes zero. So that is the meaning of neutralization. You adding both. That's why you produce only salt and water. Okay, salt and water are both neutral charge compound. Okay, they have no power at all. Okay, no power, so they are neutral. So that's why we are calling them neutralization. Okay, this formula you also see on the bottom part as well for the alkali formula. So the thing that is, sorry, I meant this one here. Right, the thing that is different though, right, the thing that is actually different is the bottom formula here. Alkali plus ammonium salt equal to salt, water, and nas ammonia gas. Yes, ammonia gas. Yeah. So Do you need to know the bottom part? To be honest, no, because in SPM they rarely ask for this. They sometimes do, but you don't need to know. I don't recommend you to know. I prioritize you to focus on memorizing this part here. So how do you memorize lah? The easiest way to memorize this is actually like just take out a piece of paper and then write down like every day you do it for 5 minutes. Very easy actually, right? And just in case you guys forgot, acid has H plus ion, and alkali have OH ion, okay, or hydroxide ion. So for example, HCl is acid, NaOH is alkali, okay. But there's also another way. Alkali, I forgot to include this, right? Alkali also have, oh, why is it so big? Alkali also have a O, okay. They have O at the end, okay. O. For example, let's see here. For example, CuO. CO, copper to oxide. This one is actually alkali, okay? Alkali. But if you notice, right, why do I keep mentioning alkali or base? Why is it always mentioned, Just in case you guys forgot lah, right? Alkali, right? Alkali is actually soluble, okay? Is soluble. Meanwhile, base is not soluble, but it's still acid, okay? Sorry, it's still alkali, okay? So alkali is just that a base that is soluble. Okay, that very simple, actually very simple. Now let's move on to the next part. What is salt? Okay, I know you guys already know how to create salt, right? Just in case for those people who do not know to this point, right? Salt is an H plus ion that is replaced by a metal ion. The keyword is replace, because if you look here at HCl, they turn into ZnCl2. Okay, this is the H plus ion, right? It is replaced with a metal ion. Okay, zinc is a metal ion. Okay, so you have to remember this definition, because they sometimes ask in the last part of the essay question, what is salt? They say, what is salt? So you have to mention H plus ion, right? Replace, right? Metal ion. Okay, those are the three keywords. So how to create one? Okay, a reminder on how to create one. So first of all, do you know what this formula is? This formula is, of course, right? This is acid, right? This is acid. This is what? What is this? This is actually, if you look here, right? This is actually carbonate metal. Why? Look here. Look here. See? There's a metal and there's a carbonate. So this is carbonate metal, right? Carbonate. I'm just going to write carbonate metal. So it should produce salt. CO2, of course, CO2 and H2O. So now, how do you create the salt? The salt is actually very simple, right? First of all, you can do the manual one. I'm just going to show the manual one. First of all, list out all the charge. So list out all the charge. So there is actually the easiest way to do this, right, is actually to take out H and this one here. So you should actually get MgCl2. Okay lah. If you don't know why, let's do the manual way again. So let's list out all the charge. So H, if you HCl, right, if you were to break it down, it become H plus and Cl minus, right? So if you were to break this down, it become Nd2 plus and CO3 2 minus. 2 minus. Okay. And then if you were to break these two down, right, these two down, you just left with CO2. I'm just going to write CO2, and then also H plus OH minus. Okay, OH minus. So first of all, okay, let me do that. Okay, this one should be 2 minus or 2 plus. Okay, 2 minus. Okay, if you were to list out all the charge, right? If you were to list out all the charge, you can actually cancel the charge. Why do we need to do that? Because we want to create salt. So let's cancel all the common charge. What do I mean by that? First of all, you can see here, H plus, right, can be cancelled with the H plus there, right? Okay. And then OH here, right, can actually be cancelled by all of this. So CO3, right, can actually cancel out OH. Why? Because it looks similar. Like what? CO3, CO2. You can cancel out, right? This one, why? Because there's O here. Oh, just focus on the O actually. Just focus on the O. And what are you left with? You are left with Cl minus and Mg2 plus. So you have to do the cross method, which is this method, right? You just have to put the charge to the front. So what is the charge of this one? -1, right? So become -1. Sorry, 1 lah, right? Just focus on the number. What is the charge of this one? 2 lah, right? So the charge would be MgCl2. Okay, MgCl2. It should be actually opposite lah. Yeah, they should be opposite. Sorry. It should be opposite. Just so that you guys can see better lah, right? Now you see, it will become 1, this will become 2. Now there's 2. Okay, that is the salt. The salt is actually very simple lah, right? So now let's travel to the salt land, right? But that will be for later. For now, let's do the last topic here. Actually very fast today. If can cover the next topic, actually good lah. So now let's do this part here, calculation. So the calculation, right, is very important. Actually, is very important. Calculation, they always ask lah in the SPM. So they will give you no, not they will give you lah, but you have to know all this formula and what is used for. So there's 3 formula that you have to know for calculation. The first formula is this formula here, the molarity, the mole calculation. The second one is dilution formula, and also neutralization formula. Of course lah, based on these 2 here, you can already know which topic they cover: dilution and neutralization. Of course lah, right? But for the mole here, right, why did I start here? Because it's very important. You have to understand. If you remember your Form 4 syllabus, right? Form 4 syllabus for your chapter 3, I think so. I don't know lah, right? Which one? The molarity calculation lah, right? The calculation part. You can actually calculate mole using different way. First of all, if you have a volume or a mass, okay lah. If you have a mass here, right? Actually, let's use quantity first. If you have quantity, right? If you want to get quantity, you have to times NA. Okay, NA. NA, Avogadro constants. Okay, but if you have volume, right? Volume, you have to times with either 22.4 or 24. This one is the room condition. This is the standard condition. Okay, if you are given mass now, you can actually times with the RMM, the relative molecular mass. Okay, so of course to get this to this, you have to times, but to get backward, you have to divide. Okay, divide. So just use common sense lah, right? For example, this one here, to get quantity back to mole, you have to divide. Okay, divide. So this is a formula, right, that we know lah a long time ago, right? But why now there's another formula? What is the difference between this formula and this formula here? The biggest difference, right, is this formula is only for solution. Okay, only for solution. So this formula is actually for a solid, solid. So you have to use this formula for solution. Okay, now let's talk about the dilution formula. Dilution formula is actually pretty easy lah, right? All you need to know, right, is dilute. Of course lah, right? Dilute. What does dilute mean? Dilute means you add water to something. For example lah, right? For example, you have Milo. Okay, for example, you have Milo. You add water to it. Is the Milo gonna be diluted? Of course lah, because you add more water, right? So it's gonna be like more watery flavor. Okay, so that is the meaning of diluted. Dilution basically means you add water. Okay, water. So the keyword here to when to use this formula, they mention lah, very easy lah. Sometimes they mention diluted, or like they add water. I mean, come on lah. If they add water, of course lah, it's going to be diluted lah, right? So use common sense lah, right? Use common sense. So that is the second formula. Now the third formula, MAVA over MBVB equal to A over B. Okay, this one is the neutralization formula. So first of all, later you're gonna understand what is A and what is B lah, right? Later you're gonna understand, but don't worry, it's very simple. But this formula is about neutralization. Now let's recap. What is neutralization again? Neutralization is when acid react with alkali or base, whatever lah, right, to produce salt and water. Okay, salt and water. If you ever see an acid react with alkali, that is neutralization. So you can use this formula here. So of course, to know when to use this formula, right, you have to look at the question and label or identify which one is the acid or the alkali. Okay, and if there's acid and alkali, just know lah, it's neutralization, and then you can immediately apply this question here. So far understand, right? It's very simple, this formula. But now let's use an actual question to test your understanding. So they say, what is the total volume of solution produced if 25 centimeter cube of 1.5 mole decimeter cube barium hydroxide solution is diluted to form 0.1 mole decimeter cube barium hydroxide solution? Okay, first of all, it's very lengthy, lah, right? Very a lot of words, lah, right? So I have tips for whenever you see this question, lah, right? First of all, if you can write the equation, you write the equation. But for this equation, you cannot. So later you understand lah why, right? But for now you cannot. Second of all, you have to label all the information you are given. So first of all, what is the total volume of solution produced? So they asking for volume lah, right? So we already know. Okay, volume. What is the that one, right? Very simple lah. Let's label them. Now, what they're giving? They give you, right, if 25 centimeter cube of 1.5 mole decimeter cube of barium hydroxide. So basically they're giving you, right, another volume lah, right? And also, what is this? This is molarity. Molarity is concentration basically lah, right? So the symbol for molarity is actually M. Okay, M. If you look here, oh sorry, I forgot to explain. M is molarity. M is molarity, and then volume is volume lah. V is volume lah, right? Okay. So they give you all of these, right? All of this. So they give you this also barium hydroxide. What they want, okay, what they want actually, you have to identify this question first. First of all, what type of question is this? Do you see any keyword here? There is a keyword here, which is diluted. What is the meaning of diluted again? Add water lah, right? So the formula that you should actually use lah, right, is the dilution formula, which is M1V1 equal to M2V2. So this is the formula that you're going to use. Okay, I'm not gonna calculate all of this to give you guys homework lah, but it's very easy actually. You guys don't even need to do it. Okay, you have to use this formula here. And you can see that there's M1 and M2 lah, right? And V1 and V2 lah, right? That means we are comparing two different substances, okay? And we have to find one molarity for one thing and the molarity for other thing lah, right? But what's the question they want? They want V, right? V1 or V2? We do not know. So we already know this, right? So we can actually apply the formula here. So let's look here. Let's look here. We can label all of them. So this V, what V are we going to use? We can use any V lah. Let's use V2. Okay, V2. So if this is V2, then this V is for what? V1 lah. V1. Okay, this will be V1. And if that is V1 for barium hydroxide, this will be M1 lah. Common sense, M1. This cannot be M2 lah. M2. Or else this will be attached to this one here. We not, right? We do not want, right? So this will be M1. Actually, no. What is the total volume of solution produced if 25 centimeter? There's another molarity here. Molarity here. This molarity is actually for what? Let me see. Let me see. This molarity is for what? To form that one. Yeah, I know this one. This molarity is for what? Can anybody answer me? M2. Yep, is M2. Correct. Smart. Why? Because, right, first of all, you have to understand what is the product, what is the reactant, right? There's a equation, right? But we cannot write equation, right? Use common sense. What is the total volume of solution produced? So you think this solution, right, is for the first side or the second side? You think which one? They give you what is the total volume of solution produced, right? So this should be the right side, right? Right side. Okay. So that one common sense, right? If this thing is diluted, so you already know this is the product. Okay, this is the product. The barium hydroxide, right, is the product. So this should be V1 M1. Okay, or the opposite, see, or the opposite. Yeah. And if this is V2, right, of course this will be M2. Okay, so you use your brain there, and of course you can just immediately use your calculator here. But I'm too lazy, so I'm just gonna substitute it, and then you guys find it yourself. So 25 centimeter. So molarity first, right? 1.5, 25. Right? Okay, this one here they give you molarity 0.1, 0.1, and then V2. Okay, 0.1 V2. So later you guys can find out V2 is something, I don't know. V2 is 375 centimeter cube. Okay, so this should be the answer. I don't know whether it's correct or not, but that's not my answer. That's someone else's answer here. Okay, so now the next question here: 25 centimeter cube of 0.2 mole decimeter cube of sodium hydroxide, blah blah blah, is titrated with 0.1 mole. What is the volume of sulfuric acid needed to neutralize the hydrogen? Okay, first of all, this question is very long, right? This question very long. So you have to search for the keyword. Search for the keyword. Okay, the keyword here is titrated, and also like they say here neutralize. But titration is better lah, right? Because in case you forgot, titration, right? Titrated lah, right? Titrated is a method in which we can neutralize something. Okay, so whenever you hear the keyword titrated, just know it is neutralization. So we already know this is neutralization, right? Now let's go one by one in what I said to do, right? First thing we have to do, write the equation, chemical equation. If we can we do that? Yes, we can actually. Because why? Because we have two solutions that we given here. So they said they give you this, right? And then they titrated, meaning they combine lah, right? Combine with sulfuric acid. So sodium hydroxide. What is sodium hydroxide formula? Sodium hydroxide formula is Na sodium hydroxide, right? And then sulfuric acid. Sulfuric acid, you have to remember this, H2SO4. Okay. So what will it produce? It will produce. This is what? This is alkali. This is acid. Acid plus alkali is salt. So the salt will be NaSO4. Of course, this is not the answer. Na2SO4. Tada, this is the answer. Just in case you guys are confused, right? Let's do here. Let's do here. Let's do here. So we have to just in case you don't know how to create the salt. First of all, we can list out all the ion here, right? So Na plus, OH minus, sorry, H plus here, right? And then SO4, 2 minus, right? Na plus. Sorry, we cannot label this out. Sorry. And then H2O. So H plus or H minus. So first of all, we can immediately cancel out this, right? Also our common side, right? What are we left with? We are left with this and this. Of course, we can combine them, right? So we are left with, let's do on the bottom. So Na and also SO4. 2 minus and plus. We can crisscross. So this you bring around the 2. This you bring down the 1. Okay. What you are left with? Na2SO4. Tada, this is the answer. Very simple actually. Just get used to it lah. Do more practice and then you will eventually know how to do the salt. Okay. Now, why do we do that? So that it's easier for us to see the formula lah, so that we can do the formula easily. So the second thing that I said to do, right, it is label, right? So label, let's label them. So this, they give you this. They give you this. They give you this. What else they give you? This one as well, right? This one as well. So whenever you have a chemical equation, right, I prefer if you label them on the equation. Okay. So 35 centimeter cube of 0.2 mole decimeter cube sodium hydroxide. So we can label here. So 25 centimeter cube. Okay, and what is the molarity? 0.2. 0.2 molarity. Okay. I label them there so that it's easier for you to see lah, right? That's the equation here. Now, H2SO4. H2SO4 is sulfuric acid, and what they give you? 0.1 mole. Okay, so you are left with 0.1 mole decimeter cube. What they ask, what is the volume? Okay, you already know, you want the volume now, right? So the volume will be V, right? So they want V. So V. Now you know this is neutralization, right? So we have to use the formula known as MAVA over MBVB equal to A over B. Okay, A over B. So this is very simple, actually, very simple. First of all, you know what is M lah, right? M is molarity lah, right? Both of these are the same molarity. You know what is A and B? A and B. Now I have to explain lah, right? A and B is the ratio in front of the equation. What do I mean? Okay, let's say this is 2 lah, right? Let's say this is 2. So that means, right? That means the ratio here, let's say this is A, right? That means the A will be 2. Okay. Oh, I forgot something. Yeah, careless mistake lah. Don't do what I just did lah. This equation is actually not balanced. You can see the equation is not balanced. Why? Because there is 1 and A here and 2 and A here. So this is not balanced. So you have to balance them. Okay, balance. How to balance them? Put 2 here. Okay, put 2 here. So now you are left with 2 oxygen, 2 oxide, and then H have 2. So there should be 4 here. 4 H. Now this one here, there's 2 H, right? 2 H only, right? So just put 2 here as well. Okay, simple. So this should be here. Now, yeah, this should be here. Anyway, the A and B basically says the ratio of something at something. For example, right, your teacher probably said right, the number in front, right, is the molar, right? But no, this is the ratio. The ratio. Like if you have to one egg, right, one egg plus like two sugar. I don't know lah, two sugar lah, right? Only then you can produce something. Okay, only then you can produce something. For example, if you don't have the egg, if you don't have if you only have one sugar, no lah, you cannot bake the cake lah, right? This is a recipe lah, right? No, you cannot lah, right? So you have to have the perfect ratio. You have to have the ratio that allow it to react with others. Okay, that is the meaning of the number in front, right? Right. So that means you have to have 2 sodium hydroxide and 1 sulfuric acid so that it can produce a result here. Okay, so that's the meaning of the number in front. So number is 2, right? So we can this formula, right? Okay, let me just go by one by like this formula. You have to compare 2 things, right? So which thing are we comparing? Do we compare for example sodium hydroxide with this thing here? No lah, we don't. Why? Because we don't have any value here. What is the value here? What is the V here? What is the M here? We don't know, right? So that's why we don't compare them. We compare with the thing that we have. What we have? We have this thing here, right? Even though it's only one, we still have something, lah, right? So we can compare this with this. So first of all, we have to choose which is A, which is B. So this can be the A, this can be the B, lah, right? This that's just comments, lah, right? Or like this can be the B, this can be A. Anyway, lah, anyway can work. So now let's substitute inside there. So M molarity for A. So it should be 0.2 and then 25 over 0.1 and then V. We want to find VB, right? Equal to A is what? 2 over 1. Okay, 2 over 1. Okay, now we can just solve this like normal. So this should be 2. This will be let me use my calculator. 0.2 times 0.2 times 25. So this will be 50. Yeah, 50 over VB. So V should be, if my math is not wrong lah, right? So this go down. Okay lah. Let's do one by one. See, let's do one by one. This should be 2. Okay. This go up. Okay, this go up. So it should be 2 times 0.1 times VB equal to 0.2 times 25. Okay, 0.2 times 25. So 0.2 times 25 is 0.5. Right? Am I crazy? Let me see it. My calculator sucks. So yeah. Sorry, 5. This is 5.
Azman,
Yeah.
can you repeat like
Re-
the second step? I tak faham.
The second step, which one?
No, the calculation.
The calculation. Oh, this one here lah.
Mana kau dapat dua tu?
Dua tu. This one, right, is A and B, right? Is A and B, right? Just now we said the ratio lah, right? The thing I said about this thing being the ratio lah, right? The number in front, this is 1, right? The number in front is 1. So if I were to say this is A and this is B, right? The B should be 1 lah, right? B should be 1. So it should be 2 over 1, right? 2 over 1. 2 over 1 is what? 2 lah. Okay? And then do you understand or not?
Dah. Thank you.
Okay. So this one should be 5. Yeah, 5. Now 2 times 0.1, 2 times 0.1 should be 0.2. Yeah, 0.2. VB. Okay, VB. Yeah, VB. So VB will actually be this move to other side. Okay, this is times move to other side. It become divide relationship lah, right? So 5 divided by 0.2. So it should be 25 centimeter cube. Tada! Very simple, actually. I hope my answer is not wrong. But you get the answer, lah, right? You get the gist of it, right? Just have to sub into the formula. Make sure you don't get it wrong. I don't know whether I'm wrong. Okay, fine lah. It's fine. So now self-test before we end this short class. Unless you want to continue lah, right? But my throat, I don't think I can handle it for now. So the self-test. CH3COOH plus Zn equal to H plus. Okay, H2. First of all, what is this formula for? What is the formula? The formula is actually, just in case you don't know, right? Actually, yeah, just in case you guys don't know, the formula, what it is? What is this? This is actually an acid. What is the acid called? This is called ethanoic acid. Okay, ethanoic acid. Ethanoic acid is also known as what? What is it known as? Cuka. Yes, cuka. It's known as cuka. What is the Malay word for this? What is the English word for this? I forgot. Cuka. What is it? Anyway, this is cuka, right? This is cuka. So that is ethanoic acid. And then zinc is what? Zinc is metal, right? What type of metal? Reactive metal, right? So acid react with vinegar. This is vinegar. Yes. Acid react with reactive metal, right? What it should produce? It should produce salt lah. Salt. Yeah, should produce salt. So what is the salt here? The salt here is actually a trick question. You know why? Because you probably think like this is gonna be Zn CH3 COO. But no, this is not it. Okay, you know why? You know why? Oh, by the way, H is not there because you know why? This is the H plus ion. This is the H plus ion. So this part here is actually the H plus ion. This one here is actually the negative ion. So do you know why this answer is wrong actually? You know why? Because you have to put the plus, right? The cat ion in the back. You have to put it in the back. So it should be that. Okay. And then is this balanced? No, you have to put 2 here. Okay. But of course, will they ever come out like this? No, don't worry. This question already come out lah. But it's just to test your knowledge, right? For long equation, you have to put the cat ion at the back. Okay, at the back. Okay, and then plus hydrogen. Okay. Now second one. So H2SO4 plus NH4OH equal to what? So first of all, what is this reaction again? Of course, you have to know the reaction. The reaction is actually, what is it? H2SO4 is sulfuric acid. This is acid, alright? What is this? Okay, first of all, you probably don't know what this is, right? This is ammonium. No, it's something like that, right? But to give you hints, right? This is OH, right? OH. What is OH? OH is alkali. Don't forget, OH is alkali. Or like if this O, right? But OH is common, more common. Now, it should produce what? It should produce salt and water. Very simple, actually. So the answer here, what is the salt here? The salt here, just do shortcut lah, right? Just take out this and this, yeah, and you combine both of them. So it should be NH4, SO, 4, that should be it, and then H2, and then is this balance? No, it's not balanced. So you have to put 2 here. Okay, 2 here. Is that balanced as well? Let's see. 2 NH4, yeah, just 2 NH4. 2 oxygen, 1 no. Okay, that's 2. So you should put 2 here. Yeah, there you go. That should balance it. Now, and also, yeah, the top one is not balanced, so it should be 2 here. Yeah. So now, HCl plus Cu. So first of all, HCl plus Cu. This should be acid plus reactive metal again, right? So what is it produced here? Can someone answer me? What is it produced here? What is the product? No change, nothing. Someone in my chat said nothing. So actually, that's the true answer here. If you answer with CuCl too, that is wrong. You know why? Don't forget, just now we learn, right? This is okay. First of all, what is this? This is acid, right? And then this is also reactive metal, right? But is this reactive metal? Is this actually a reactive metal? No. Cu is not a reactive metal. Why? Look here. Look here. The electrochemical series. Where is Cu located at? Here, right. Is it under hydrogen? Yes. So this is not reactive. So it doesn't produce anything. So the answer here should be nothing. Okay, nothing. Now define salt. Okay, define salt. This one very simple, right? The answer is H plus ion. Okay, that is replace. You have to mention the keyword here. Replace by a metal ion. Very simple, right? Very simple. Now, what is base and what is the difference of base compared to alkali? This is a K-bar question, right? But the answer is very simple. Just now I said to you, right? What is the difference between base and alkali? Alkali is just soluble base, okay? Soluble base. That's all. It's just soluble. Meaning, right? Meaning, if it's soluble, it is alkali. If it's not soluble, it is a base. But it still is alkaline. Okay, it's still an alkaline. Okay. Now, what's the difference in the mole formula? Okay, this one also I just thought lah, right? The mole formula M equal to mv over 1000. This can only be used for solution. Don't forget, this can only be used for solution. So, this is the self-test. Tada! Very simple class today. Okay, so today we're going to continue the chapter 6. We're going to continue with the salt topic and basically the solubility of salt and how to prepare them. Okay, so later we're going to, if we have time, we're going to focus, we're going to also do anion and cation, how to identify each of them lah. It's actually very simple, but you have to memorize a lot. This is actually like most of the memorizing you're going to prioritize is this one here, these two here. So now solubility of salt, there's 4 rules to determine whether a salt, right? A salt is not assaulting, not assaulting lah, but like a salt, right? Salt is soluble or not soluble. That's very easy to understand, right? So the first rule, right, is actually no spam. Is meaning, right, anything with the no spam is soluble. For example, MgNO3. No spam. No spam means nitrate, sodium, potassium, and ammonium. For example, MgNO3. Mg magnesium. NO3 is nitrate. So yes, nitrate. Nitrate means is soluble no matter what. No matter what. Okay. Now, subacap, the second one, the subacap and the copacmer, both of this bottom one, right, is insoluble. Okay, insoluble. So subacap means, right, sulfate, barium, calcium, and lead. But you have to combine sulfate with these three here. So meaning it's not like if you have lead in the equation is immediately insoluble. No, it doesn't mean like that. It means that sulfate has to combine with all of this. Okay, all of this. So now, oh my god, someone got straight A. Wait, who's that? Cannot see. Is that Nick or uh who's the Indian guy? I I'm forgetting. It's not Praveen. Who's the Ashira's girlfriend? Boyfriend. Who is it? Oh my god! Wait, who is it? I.
Derek lah, Derek.
Oh, Derek. Yes, Derek. Derek. Oh no, he got say yeah. Is it? Wait, nice. A lot of A plus actually.
I'm sorry,
Nice.
but where
Okay.
did you see the result?
Uh look at PRS group. Oh, Fahim also.
Oh,
Fahim got what? A plus, A, B plus, Bahasa Melayu B plus, Sejarah A plus, Physics A minus, Kimia B plus. Oh my god.
Chat, I got Pravin's one.
How much?
Okay, VMB, yeah.
Uh-huh.
Chemistry B plus.
Chemistry? B plus?
Uh-oh.
Uh-oh.
But physics A minus.
Physics A minus. Okay, that everybody got A minus. Oh, normal lah.
Overall, just 3 A's for him.
3 A's. Nice, eh? He's got nice. Yeah, I thought he pro in chemistry as well. You.
I don't know. I I'll boss him later when he comes over.
Wallah, teaching, but still not good. Nah, joking lah, joking. Holiday best. Who got straight A? Derek. I think Derek got it. Oh, straight A plus. Ooh, I don't know. I see. It's not Derek for sure. Where do I send it to?
Nick got straight A but 2 B's, right? 2 B plus.
Who? Derek?
Nick. Fahim.
Yeah, yeah. Only one? Oh no. Fong?
Where?
Oh, Fong.
Telegram tak ke?
Telegram tak ada.
Then? Yeah, I'm sorry,
Yeah.
right, guys. Today we focus on class.
You want me to focus ah?
Covered tadi nak focus dulu. Sekejap.
Okay.
Can you go back to the no spam?
Okay, yeah. No spam, right? No spam. Why is it no spam? Because please don't spam this group, okay? Anyway, no spam means anything with no spam, which is nitrate, sodium, potassium, and ammonium. Mara, what is the formula for ammonium?
Ammonium.
Say yes or no if you don't know.
No.
Okay, so
Sudah
you
no,
do
sudah
know.
no.
Okay. Surya, you know what is it? NH4. No, it's NH3. Nah, joking lah. It's NH4. It's NH3. NH4. Okay. So anything with this thing here, right, is 100% soluble. Okay, 100% soluble. Now, subacap and copacmer. Subacap means, right, you have to have sulfate and also these three here for it to be insoluble. For example, sulfate and let's choose these two here, right? So Pb 2 plus, right, for lead, and sulfate is this symbol SO4. Okay, 2 minus. If you combine them, right, PbSO4 lah, right? So is this insoluble? This is insoluble. Yep, it is insoluble. But if you were to combine with Ca, this is also insoluble. Why? Because calcium. Okay. But what if you combine with MgSO4? This is soluble. Soluble. Be careful. Anything sulfate, right? Sulfate. It has to combine with subacap. It has to combine with calcium, lead, or barium. Barium, you don't need to know the formula lah, but barium is Ba. Okay, Ba2 plus. Okay. So that is subacap. Now copacmer is the same deal, but except it's chloride now. Okay. Chloride, lead, silver, and mercury. Mercury formula is Hg, but you don't need to know that one because they already come out. So the only thing that will matter is chloride. Okay. So let me show another example. Let's use silver and chloride. If I use silver, all right, and chloride, right, this will be insoluble. Okay, insoluble. But if I were to use, let's say, zinc Cl2, is this soluble? This is soluble. Okay, just look at where whenever they give you an equation, right, you should always look for chloride or sulfate. Okay, and then see whether it partner with anything or not. Okay, that's all it is. And then core is quartz or whatever lah, right? Carbonic oxide or hydroxide. So anything that end with CO3 or yes, or H lah, right? This is insoluble. Okay, insoluble. For example, Ag or H, right? This is insoluble. Even like Zn2 or H. Okay, so this one will be insoluble as well. Now, question here, you can answer in the text box or speak lah, right? The test question here. So you can see there's a beaker here, right? There's a beaker here. There's salt inside there. Okay, when you add water, this turn out. What is this? This is basically the salt is dissolving in water. So what is the salt? Can someone answer me? What is the salt? Is it A, B, C, or D? Let me write the rule here. Okay. B. Okay, ada answer B. Surya, what do you answer? I mean, I don't think he knows. B. Might also answer B. So let's check whether you guys are correct or not. That took a long time, lah, right? But because you guys are like not new, you guys probably forgot the rule. But it's fine, it's fine. Do it slowly. So let's do one by one. It has to be soluble, right? Soluble. The characteristic is soluble, right? So let's do one by one. Zn O, is that soluble? Is that soluble? Zn O. What is O here? O is actually involved with core, okay? Core. Oh, you who just joined. Oh, the Atil, okay. So core is also insoluble. So this one is already insoluble. Now let's start with B. PbSO4. PbSO4 is lead and sulfate, right? So let's look at sulfate. Is there lead here? Yes, there
Wait.
is. So this one here. Yeah. Why?
Can you explain like no spam?
No spam.
Yeah.
So which one? Which one is the answer?
No.
Let's see here. Oh, you want me to explain now why is no spam?
Yeah.
No spam. Anything with no spam. What is no spam? No spam is nitrate, sodium, potassium, and ammonium, lah, right? If anything has no spam in the equation, for example, let's see here, AgNO3. This has no spam. You know why? The nitrate. No, lah, right? Let's see. No spam. Let's use sodium now. Sodium is Na, right? Okay, no, Na. Okay, and then NaCl. It is no spam? Yes, because why? Sodium. Okay. Now potassium. K. Let's use Ki. Right? This one potassium iodide. Potassium iodide is soluble or not? Soluble lah. You know why? Because no spam. No spam lah, right? So, you understand?
Yeah.
Okay. Now, you answer now. Which one is soluble? Because the question is asking for solubility, right? So which one is soluble? Just now I said this is insoluble. This one I didn't answer yet. So is it C, D, or B?
Azman, can I choose my answer?
B.
Alamak.
B.
This one here. This one?
B. Bola.
B, bola. Okay, bola. Okay, your answer is bola. Adia answer is wait, let's see. I forgot. B as well. And then Myra, what's your answer? You want to change?
No. I was having thoughts. So I was
Okay.
antara C or B. So I choose B.
Okay. PbSO4. So the only thing in the rule that I said is soluble is this thing here, right? No spam. If any of these things happen, it's like a couple, right? So subacouple. What is the couple here? The couple sulfate has to couple with these three here for it to be insoluble. If sulfate is coupled with none of these, right, it is soluble. Okay? Copepmer is the same deal. Chloride. It has to couple with these for it to be insoluble. Insoluble. So PbSO4. Subacouple. Pb. And then SO4. So this is insoluble, not B. The answer is not B. Okay? That's a mistake there. And remember, the only way for you to know whether something is soluble, right? Here's my tips, right? Just to go from number 1 to the bottom. So go from the top. The top is the spam rule, right? Look at the spam rule. Is there anything that apply here? Yes. This one here. Na. Okay, Na. But we probably have a question, right? This have Na. Sure, yes, no spam. That means soluble. Confirm lah, guaranteed. There's no way lah, right? And then this also have OH. OH is insoluble. Why? Normally, the more you do it, the more you get used to it. Core. Core is what? Carbonate, oxide, and hydroxide. So there's two, insoluble and soluble. So which one will be prioritized? This is actually a question that they always ask, right? They give you this to trick you up whether this is soluble or not. The answer is very simple actually. It is soluble. It prioritizes the soluble. So the answer is C. And of course, D doesn't work. You know why? Look at the chloride. Chloride. So copacmer. We use copacmer. Chloride and silver, right? Silver chloride. There's silver here and chloride here. So this is also a partner, right? So this one is also insoluble. Okay, understand?
Yes.
It's confusing, but don't worry. If you want, I can give you homework lah, right, later. Now, let's do preparation of salt. Okay, preparation of salt, right? They always ask in the essay question for SPM sometime lah, right? But actually in SPM lah, they prioritize like the easy chapter, like chapter 8, the metal alloy and so on, right? They always prioritize that one. But sometimes it do come out the preparation of salt. Preparation of salt, typically they give you like 8 marks. 8 marks. And it's very easy. Don't worry, you can do it. Okay. So preparation of salt. We are trying to prepare to create the salt. We want to create the salt that we want. For example, they give you like prepare the salt for barium chloride. Okay, barium chloride. So later on, you're gonna know how to prepare the salt. Okay, so if you want to create barium chloride, what do you have to do in your lab? Okay, so preparation of salt. First, you have to go to a list to see which method you want to use to create the salt. There's 3 methods. There's 3 methods here. Double decomposition method, acid reaction, and titration. Okay, these 2 here are basically the same, but this one here will be a different thing here, a bit like somewhat a bit. So you have to go to a list. You have to go to a list. The first question that you have to ask to yourself, right, for the salt, is the salt soluble? If it's no, then you have to use this method here. Okay. If it's yes, does it contain spam? Okay, spam. I didn't include no. I didn't include no. I only include spam. Be careful, spam. So if it's yes, then use titration. If it's no, you use acid reaction. Okay. Now you have to always remember this flow chart here. This flow chart here will help you in understanding the like create the correct or like use the correct method, or else you will use the wrong method and you get different salt. You want the salt that you want, right? So let's go one by one. The first method we're gonna see lah how to do, right, is the double decomposition or precipitation method lah, right? So they ask you, describe the procedure to prepare lead to sulfate. Lead to sulfate. Okay, first of all, PbSO4. Okay, PbSO4. Is it soluble or not? Okay, focus on the anion. Just always focus on the later back lah. So sulfate. Is there anything related with sulfate? Yes, there is. Subacap. Okay, I recommend you to like write down this paper lah. Right, write down this so that it like you can easily see what is the partner. So sulfate. Okay, sulfate. Right. Now the partner that he has is barium, calcium, and plumbum or lead lah, right? And he has lead, right? That means this is insoluble. Okay, you already know the first step, insoluble. Then you have to use this flow chart. The flow chart you have to memorize lah, right? But the flow chart is like this one here. So you have to use this flow chart. Just now I said, right, is the salt soluble? No, right? PbSO4 is not soluble, right? So you have to use this method. So now you are going to see how the method works. So the method concept, right? The concept is basically like this. First, you have to put 2 soluble salt, okay? 2 soluble salt, and then they will exchange partner to form 1 insoluble, 1 soluble. For example, look here. Look here. So this is okay. This is the first salt that we're going to use. Right? It is soluble. Yes, because why? Always look at the back lah, right? Or yeah, always prioritize the back. The back, right, is nitrate, right? Nitrate and O3. Yeah, nitrate is no spam. Remember the rule, no spam? No spam is always soluble. So this is always soluble. Okay. Now the second salt we're going to use is NaCl. NaCl, look at the back, chloride. Chloride, right? So look at chloride. Is there any chloride here? So copacmer, right? Copacmer. So chloride has to pair with lead, silver, and mercury. Is there any of that? No, right? There's sodium, right? And sodium, of course, you know, right? It's from no spam as well, right? You can use either method, right? But you already know this is soluble, right? This is soluble. So this is also soluble. Now the next one, we have to know how to exchange the partner. So to exchange the partner, right? Basically, you're just going to take the positive here and also negative here, and you will form a different salt from that. What do I mean? So just take it up. Just take the silver and chloride. You combine both of them. So AgCl. Okay. So far, do you understand? It's very simple, lah, right? You just exchange the partner. Like, yeah, you can also do like this. Like, if you are confused which partner we want to change that, right? We can also take this thing here and also this thing here, right? But why did I do that? Because this part here also lah, you're gonna do anyway, right? So either way, you're gonna get two different salt here. Okay, either way, you're gonna get two different salt after you exchange the partner. Okay, so far understand? You just take this and this, and then the leftover you combine. Okay, that's all lah. Basically, that's all. That's all. So now you look at right, AgCl. AgCl, is this soluble? First, look at the back. Always look at the back lah, right? Chloride. Chloride. Why is chloride involved in? Copacmer. Right? Just don't forget copacmer. So chloride. Okay, he has to pair with lead, silver, and mercury. So is there lead, silver, or mercury? Yes, there is silver. There is silver, right? So this is insoluble. Now look at here. Sodium nitrate. Okay, sodium nitrate always is soluble, lah, right? They has no spam, lah, right? Yes, no, both of the no spam. Yes, the sodium and also the nitrate spam, right? So this is AgCl here. Okay. So far understand, right? This is the concept of precipitation. Okay. Okay. So the topic we're going to learn is precipitation. Precipitation means basically right. The product later on, right? You're going to see like some precipitate. Okay, precipitate. Like for example, if you have a solid right, beaker with water. Okay, water right? Water. You're gonna see like some like white stuff on the bottom. Okay, like collection of white stuff. This is called precipitate. Okay, precipitate of course have different color lah, right? But all you need to know, like, that is the meaning of precipitate. Precipitate means there's gonna be a solid, okay, produced. Now the concept will be soluble salt plus soluble salt. It will produce insoluble salt and soluble salt. So soluble salt means something soluble. For example, look here, right? AgNO3. AgNO3 is actually soluble. You know why? Look at the back one. What is the back one? Nitrate. Nitrate is actually in no spam. So this is soluble. Okay. Now NaCl. NaCl, it is soluble? Yes. Look at the back. Okay, the back is chloride, right? What is involved with chloride? Copacmer. Okay, copacmer is involved with chloride. So this is also soluble. You know why? Look here, copacmer. It has to be paired with lead, silver, and mercury. This is sodium. Sodium, of course, doesn't pair up with anything. And also, of course, sodium is also in no spam. Okay. Now, and then you're gonna see, right? This precipitate, right? It will exchange partner, okay, to produce something. Okay. So what does it mean by? So basically, what it means, right? You're just gonna switch partner. Okay, you're just gonna switch partner. You can see I colored, right? I colored. So I'm gonna switch partner. How do I do that? Basic, simple, right? So Ag from this side here will combine with Cl from this side here. So it produce AgCl. Okay, and then the leftover you can also combine Na combine with NO3. It produce NaNO3. So this is the formula for precipitation. Precipitation is soluble plus soluble, produce insoluble and soluble. How do you know whether this is precipitation? You have to make sure that the partner you exchange, right, produce an insoluble salt. Okay. So for example, this one here, it is insoluble. Yes. You know why? Look at the back. The back is chloride. Chloride is involved with what? Copacmer, right? Don't forget copacmer. So look here, copacmer. He has to be partner with lead, silver, and mercury. Look here, that's silver. So this is also insoluble. And of course, this is soluble. You know why? No spam. Okay, no spam. You have to get used to this formula. This method shortcut here. Okay, of course, sodium and nitrate. So both of them are soluble. Okay. So they ask you describe the procedure to prepare lead to sulfate. So they want PB, and also SO4. First of all, you have to know, just now I said, right, you have to look at the flow chart. The flow chart we're going to use is precipitation method, right? Precipitation method, right? So I'm just going to write PPT method. PPT is like precipitate, right? Precipitate. PPT method. So What is the PPT method? You have to get this one, right? Why I put here? You have to get this one, right? So this is insoluble, right? This is insoluble. So this is actually here. This is actually here. So what we want right now, right? What we want is actually these two soluble salt. See, this is why it's called preparing a salt, because we do not know what two salt we're gonna use to create this salt here. That's the difficult part here, right? So actually, it's not difficult. Just look here, right? Okay, PbSO4, right? Pb, the first partner, right, from salt one. Look here. Ag, right? What's the first partner from? This one, lah, right? Common sense, lah, right? Cl, where's the partner for? The second one, lah, right? So, Pb. So, Pb, the partner will be Pb something, something, lah, right? Something, something. And SO4, the partner will be something, something, SO4. So far, understand, right? So, what does these two SO4 XX have to be? It has to be something that make it soluble. Soluble. You want soluble, right? You want soluble. See, you want two soluble thing. You want two soluble thing, right? So you have to use what? What method you have to use? You have to use no spam. See, very easy, right? You have to use no spam. So look here, right? PbSO4, right? PbSO4. You can use Pb and O3. Pb and O3. Look at the no spam. Which one is a cation? Sorry, which one is the anion? Anion is the back one. Only this one, alright? This is all cation. Why? All of these are positive charge. What you want right now? What you want right now? You have Pb, right? You have Pb2 plus, alright? What you want right now? You have something negative, right? So of course you're gonna take NO3. This is nitrate, right? So you can combine them. You will get Pb NO3 bracket 2. Okay? That's the first salt that we want to find. Second salt, we want to find something, something, SO4, right? SO4. So look at no spam. What we want here, oops, sorry. What we want here, we want something positive, right? Look at no spam. Which positive we can use? Negative, we can use any. So I'm just going to use Na, okay? I'm going to use Na, okay? And then to balance this is plus 1, right? So Na, you have to put 2 here. So this will be balanced. Look here. Ta-da! Simple, right? So basically you have to use no spam, right? No spam to get it. And this is the formula. So PbNO3, 2, because there's 2 of them, right? Plus Na2, SO4, will produce this that we want. And this, okay? This, where we get this from? Of course, once we get the partner, right? We got the partner, we swap place, right? We will exchange these, right? The leftover, we can combine, okay? Combine. So Na plus NO3 will produce NaNO3, okay? And then why did I put 2 here? To balance it out, right? We have to balance it. Don't forget, we have to balance it. So this is the formula. And from here already, you already know which salt we're going to use to produce this salt. Okay, we want this salt. Don't forget, we want this salt. They're asking you, right? I want to taste this salt. No, don't taste this salt. This salt is don't taste. This is sulfuric lead. Okay, don't taste. But yeah, you get the point. We want this salt. So you have to know which method we have to use. This method is called the precipitation method. Now, the way we have to write the precipitation, the preparation is actually like a long line. You know, like in the module book that some school give, right? You have to write something like pour into such thing, and then stir with glass rod. So this is hard to imagine and memorize, you know. So my method, the one that I learned, right, from my favorite teacher, right, is to use visualize. You have to use diagram method. Okay, diagram method. So now use diagram method. So use common sense, common sense. What you want right now? You want these two sort, right, to combine, right? So how you combine them? Of course you put both of them in the same thing here. Of course common sense So, and then if you want to combine them, you have to stir them up right? Or else they will not combine, they will not mix fast right? You want to mix fast you want to make it faster right? So you have to stir with glass rod, okay? You have to stir with glass rod. Common sense, use common sense right? And then what will happen? You will get this thing, right? You will get this thing here. What is this again? This is the precipitate. And this is soluble, right? This is soluble. Remember, this is soluble. This is insoluble. So you will actually get something like this. Look here. NaO3 just now, right? The soluble. it is the water, the liquid here, lah, right? And this insoluble, it will gather at the bottom. That is why it's known as precipitate. Okay. Now, we want only the salt, right? We want only the salt, right? We don't want this, right? We don't want this, right? So how do we do it? Of course lah, with filter. We filter to a like filter paper lah, right? Filter funnel, sorry, filter funnel. And then we will left with this one here. And then here's the tips to ensure you get full marks. Of course, this is already like 3 marks already lah, right? To ensure you get full marks in SPM, focus here. Salt must be solid, clean, and dry. What does it mean? Salt must be solid. It cannot be water. Okay? It cannot be water. No. Or like liquid. Sorry. It has to be clean. Meaning the salt doesn't have any impurities. Okay? And it has to be dry. Of course lah. Why? It has to have no water. Okay? Water. It has to dry so that there's no water. So this one you have to memorize. You have to remember this to get full marks. So what does this mean? What does this mean? Basically, look here. Okay, now we have this, right? Is this salt? First of all, you have to ask, is this clean? Sorry, is this solid? Of course, this is solid, right? Why? This is the precipitate, right? This is the precipitate, right? So this is of course solid. Okay, somewhat solid lah. It's a bit liquid, but it's still solid lah, right? Now, is this clean? Is this clean? To ensure that it's clean, you have to use what? You have to drop some water droplet on it, right? You have to drop water droplet on it so that you can clean it. Okay, you can clean it. So that's the meaning of clean. Okay, first you done clean, check. You done with solid, right? It's solid now, right? Check. Now is it dry? No lah, you just wash it with water lah, right? So how you dry it? You have to put the salt in between 2 filter paper, and then you have to like pat it. You have to pat until like it dry. Okay, and tada, you have the salt in this form here. Okay, understand? Edible salt. No, it's not edible salt. I mean, it's like a one-time edible salt. Yep, you can only eat one time before you die. There you go. So it's very simple, lah, right? You have to visualize. Of course, when in exam, lah, right? Don't answer like this, Don't answer like this. You think they gonna mark? Oh, nice, eh. Oh, nice. Okay, so smart. No lah. You have to write in full sentence. So how do we actually write this in full sentence? Later I'm gonna explain. But for now, very simple, lah, right? Use common sense. If you the step here, there's 2 steps here. The step here, right? The step here, combine. Okay. The last step, right? The second step, you have to look at the SPM thing. Look at this. Okay, you have to look at the whether it's clean, dry, or solid. Okay, you have to make sure it's all of these 3 here, or else your salt won't be counted as salt. It won't be counted. So now we done the first method already. Very simple. This is probably like very confusing for some people. It's very simple. So now let's use the second method. The second method is titration. Titration, don't forget the flow chart. The flow chart is like this. So first of all, soluble. Is it soluble or not? If it's not, we use what? Precipitation method or double decomposition method. Alright. So second is yes, right? Yes. It contains spam. So if it's no, right? No, you use acid reaction. Okay, don't forget this flow chart, actually very important. If it's yes, we use titration. So titration is very popular popular question they ask because there's a lot of information you have to know. So titration, already know from our last session, titration is neutralization. Okay, neutralization. Okay, you are trying to neutralize something. So the formula is this one the one that you already know right? So you have to use this formula. And titration, you have to set up this equipment. Okay, this equipment. You have to set up a burette and also like a conical flask on the bottom. You put the acid here. You put the acid here, not the alkali. Do not put the alkali there. Okay, do not put. You have to put the acid here. Okay. So you put the acid here, you put the alkali here. Okay. Now you have to also put a special thing inside known as indicator. Indicator. I want to ask, does anybody still remember the indicator that we use in we learn? Say yes or no. Yeah. Okay. What's the indicator that you know? Indicator that you know? I forgot. Ping. No, the indicator is not called ping. What is the name of the indicator? There's two indicator that we'll have to learn in SPM and Form 4. Phenolphthalein, yes. So why do we need to use phenolphthalein? Phenolphthalein tell us what is the color change that happen. See, if you put phenolphthalein inside here, right? This is alkali, right? Alkali. And if it's alkali, phenolphthalein will be green, sorry, pink color. So this thing here will actually color pink, it will be pink. And then the more we added this, right, we will actually turn it from pink into colorless. We will be colorless. The solution will be colorless. Yeah, it will be colorless. That means the reaction has finally been neutralized. Okay, that's the meaning. Okay, so we have to use phenolphthalein. Okay, of course we can also use metal orange or methyl orange. Right, we can use this one. Right, so if it's yellow, the first thing it will be yellow. Right, and then once you put enough, and then once it reach neutral, it become orange color. Once you see orange color, of course, right. And then why? Sometimes they ask you this. Actually, sometimes they ask you this. Why is the function of the white tile? What is the function of the white tile? White tile. I cannot say. What is the function of this tile here? This tile here, actually, this is K-Bud question. I don't know why people cannot answer. The tile is actually for you to see better the color change. Okay? Because imagine you're seeing from here. It's very hard to notice the different color, right? So that's why you have to put the white tile here. White tile here actually allow you to see the color change. Use common sense. Okay? Common sense. And then they say, what is the endpoint? The endpoint. What is the endpoint? Is it the endpoint? I think yeah, they call it endpoint lah, right? Something lah, I forgot lah. Right? But endpoint is basically when this combined with this, right? It finally produce the thing that we want. Okay, the sort that we want. So the endpoint is when the point, when the neutralization has occurred. Okay, that is the endpoint. Now, the first thing we have to do it one by one. Okay, we have to drop it one by one slowly, slowly. And then we have to stop once the indicator change color. Okay, that's the second step. Okay, the third step, we have to do it again. Okay, let me ask you again. Why do we have to do it again? Because what do we want in our salt? What do we want? We want salt, right? Do we want water? No lah, right? But of course that we can get rid of that way later lah, right? But what we also don't want, right? We do not want indicator inside this solution, right? There's indicator as well. That's why we have to do it again without the indicator. Okay, you'll probably have a question now, right? Then why did we do with indicator in the first place? So that we can measure how much acid we have to use to neutralize the alkali. Okay, very simple. So the second time we're going to use it, right? We're going to do it. This time we're not going to use the indicator, and this time we're just going to pour, right? Drop the thing, right? The required amount. We're not going to go pour in excess amount. We're going to pour the exact amount. Okay, exact amount. Okay, so that's why you have to use without indicator now. The second time you have to use without indicator. Okay, now what we are left with, right? We are left with water as well, right? We are left with water. We don't want water. Why? Remember in SPM, right? What they want? They want it to be solid, right? Solid. They want it to be clean, and they want it to be dry. First of all, is it dry? No. Is it solid? No. Actually, it's not. You know why? Look here. Does it look solid? No lah. It's soluble. Remember, look here. This is the sort that we want, right? Ask yourself, is this soluble or not? This is soluble. You know why? Look here. Look at the back. Okay. Sulfate. Subakap lah, right? Subakap. Okay. Sulfate has to partner with barium, calcium, or lead. Is there any here? No lah, right? There's sodium. Sodium is no span. So this will be soluble. And imagine you put something soluble in water. Of course, it's going to be mixed. Okay, and then it's going to turn into a mixture. This is the keyword here. The important keyword here, mixture. Later, you're going to include this. All right. So that's why we don't want the water here. Okay. Now, this is why I always advise you to remember this thing here, because you can always ask lah each step here. Okay, just look at each step, right? Okay, first I have to put this thing here. I have to do this thing. Now I have to ask: is the salt clean, solid, or dry? No, it's neither of them, because you know why? There's indicator. Then I have to do it again. Now I have to ask again: is it solid, clean, or dry? No, why? Because it's not solid. I want only the salt. I don't want the water. So that's why we have to go through this process of getting rid of the water. Okay, the process of getting rid of the water, right, is it's actually a fun one, right? If you know lah how to do it, it's very fun. So the process is actually called crystallization. Okay, crystallization. When we turn something liquid into solid, this is called crystallization. Of course, not all liquid into solid, lah, right? But some liquid. So how do we do it? First, we put the solution that we want, right, to be liquid into solid, right, in a ceramic pot, or like or in like crystallizing this. I think that's what it's called. I forgot lah. I forgot what they call it. Crystallizing this. Is it? Don't know. In the textbook, it doesn't say anything. But it's something lah. You have to put in something lah, right? And you have to hit slowly. Okay, you have to hit slowly. Okay, the keyword is slowly. Why? Why the keyword here? Why? Okay, first of all, why do you need to hit it? Because we want to burn the water. We want to dehydrate the water. We want to evaporate the water, lah, right? So that's why we have to burn. You have to hit it. But why slowly? So that we also don't get rid of the 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 salt that we want. Okay, because salt also have melting point, boiling point. They have boiling point, they have boiling point as well. Not all, everything have boiling point. So that's why you have to heat slowly, okay, until all the water is gone out, and then you're gonna see like some crystal forming. This is, you're gonna have to cool it down. Okay, you have to cool it down, because then it will actually turn into a crystal. Crystal is solid, crystal solid. Now you have to ask this crystal, right? Don't ask the crystal, but ask yourself. Sorry, I said it wrongly. But you have to ask yourself, okay? Is this crystal, first of all, remember, is it solid? Yes. Is this clean? No. Is this dry? No. Okay? So you have to do all of this. The next two steps, clean or dry. So how to clean it? Of course lah. You're gonna drop some water again on top of it, so that all the excess something lah, like impurities, will get rid, okay, will be on the bottom. Okay, so you have to clean it, and then lastly you have to pat it. Okay, pat it. Simple, actually, very simple. Now the last method here, acid reaction. Okay, acid reaction is the most simple one, right? The most simplest one, because okay, first of all, acid reaction, what does it mean? Basically means every acid reaction, right? Like acid plus something, acid plus carbonate, acid plus alkali. But you can see here, why did I cross this out? Because acid plus alkali equals salt and water. This is titration. We don't want titration. So we're not going to use that one, alright? We actually going to use this thing here, the top one. Okay? Carbonate, we can use it lah, but the metal one is better. I don't know how to use the carbonate actually, but all you need to know is how to use the top one. So you're gonna need a reactive metal and the salt that we want. Okay. My throat is dying out. So what they want here? They ask lah. The question, I forgot to write lah. The question, they want to find MgCl2. Okay, they want to find MgCl2 salt. So MgCl2 salt, you have to, how to create it? Okay, first of all, you have to know, you have to go through the flow chart again to see which method you have to use. So it is soluble. Okay, it is soluble. If the answer is no, then you use the precipitation method. Okay, If it's yes, then we have to say, does it contain spam? Okay, does it contain spam? No spam. So if it's no, we have to use acid reaction. So where are we now? We are in acid reaction. Okay, but of course I'm just gonna write it titration just in case you guys forgot. Okay, always remember this flow chart here. This flow chart is very important, alright, so that you can get full marks. So MgCl2, is this soluble? Yes. Okay, does it contain spam? No. So this is the thing that we're gonna use. Okay, now of course now we're gonna use the reactive metal. Reactive metal is like this, alright. So I'm too lazy to explain because I assume that you guys know already, right? We want to use an acid. So what acid? Look here lah. MgCl2. What acid? Of course lah, HCl. Why? Because Cl. Are we gonna use H2SO4? No. Okay. Are we gonna use HNO3? No. Because we have Cl. We have Cl. So we use HCl. And then Mg. Mg come from the Mg lah. This is reactive metal. Remember, reactive metal. There's no combination. So all you have to use is the Mg. Okay. And then plus H2. That one later lah, right? But this is the formula. And then just look here. Just look at the look at the equation already. You already know how to combine them. Actually, it's very easy. It's very easy. You already know from here what to do. You have to put something, an acid, and you have to put magnesium metal. Is this liquid or solid? Here's the question. Is this liquid or solid? The answer is solid. Okay, this is solid. Don't forget. This is aqueous. Okay, so you have to put acid and metal, magnesium metal. Alright. So just do lah. Look, I just put magnesium powder into the acid. Come on lah, dah. Use common sense, and I have to stir lah. Of course, you have to stir lah, right? Or else it won't combine lah, right? And then you will get MgCl2 mixture. Why did I underline this word? Because this word is how you're gonna write in the process, the procedure. This is what you have to use to explain the combination of two things. Okay, and then when you add this, add this. Make sure you add in excess. Why? Okay, they always ask this question also. So they ask you why? Because to ensure all the acid is has reacted. My English grammar is not good. So you have to use excess amount of magnesium powder so that you will guarantee that there's no longer an excess or like extra left over. Okay, simple common sense, right? So that's why you have to use excess. And if of course if you use excess, right, you probably gonna have some extra bit down there, right? So you already know what I'm gonna say, right? Ask this: is this, first of all, is this solid? No lah. Okay, we already know solid. It's not. Is it clean? No lah. There's impurity. Look, there's bottom here lah. Is it dry? Come on lah. There's water here. So no, it's not, right? So you have to filter it. Okay, you have to filter it, and then you're gonna get the MgCl on the bottom. Okay, this is the magnesium powder on the bottom. Alright, on the top. On the top. So this is the thing that we want. Okay, that is the thing that we want. The thing that on top is the thing that we do not want. So now ask again: is this clean? Is it solid? Is it dry? Okay. So my question to you: is it solid? No. You know why? Look lah. Look, does it look like solid? Plus. This is MgCl, right? MgCl2. This is soluble. If you see anything that is soluble, just know it's somewhat liquid. Okay, of course, not all soluble are liquid, right? But just know that is how you know whether it's soluble or not, or like liquid or not. Okay, very simple. Now it's not. Is this clean? No. Is this dry? No. Of course, not all of these are right. So that's why you have to use the crystallization method. So you put this into this, and then you heat it slowly. I almost forgot the word. Slowly. And then you have to cool it down. Okay, and then you have to ask it again. Ask it again. Is it solid? Yes. Is it clean? No. Is it dry? No. So you have to clean it. clean it like that, and then you have to pat it. Okay. So far understand? So far understand? Answer in the chat box. Is it understandable? Yes. Yes, right. So this is very easy lah, very easy. But in the module lah, right, the module is very like hard. There's a lot of question, but you don't know what to do. So now let me teach you an actual way to answer this question lah, right? Of course you cannot answer in diagram method lah, right? Or else like the teacher will ask you, who are you? Why you answer like this? This is so weird. Come on lah. It asks like in a simple way, and then you answer in the diagram way. So how to answer properly? Okay, I'm not finished, right? But you have to mention. Okay, you have to mention. So let's see here. Actually, let's do together. Let's do together. Let's do together one question. Just one question. Okay, just simple one question. Let's do see here. Let me see. Now, let's do. They ask you prepare a salt for NaNO3. Okay, NaNO3. Okay, first of all, what method you have to use? Of course, remember you have to use the flow chart. So what's the flow chart? The flow chart is like this, alright. You have to use is it soluble? Okay, is this soluble? Okay, you already know lah. This is soluble. Why? Remember, no span. Okay, this is no span. So this is soluble, right? This is soluble. So already yes, I'm just gonna shortcut. So this is soluble. Does it contain span? Yes. Okay, so your only method is titration. Okay, titration. So titration is what? Acid plus alkali. Okay. So let me write the thing here. So we want NaNO3. Okay. So we want an acid and we want an alkali to combine together. So what is the acid and the alkali that we're gonna use? Of course, remember this is gonna be like the partner swap, right? Partner swap. Of course, the double decomposition method, the precipitation method, right? Also the partner swap, right? But this is also another partner swap. Okay, so Na, okay, NO3, NO3. Okay, so what you want here? We want something that is soluble. Both of these has to be soluble, right? But you have to choose an alkali and also alkali and acid. Okay, acid and alkali. So first of all, acid, right? Okay, to create this, I forgot to explain, right? How do you create the equation? Because sometimes people don't know, right? Acid. What is the only like thing that we know about acid? Acid is H plus, right? Alkali is OH minus, right? And tada, you already have the ion here. So we can just combine lah. This plus with this one here. Why? Because it's missing a plus, right? This one here is missing a negative, right? So NaOH. Use common sense. Common sense. Okay, understand? So very simple. So this will be H and O3. Because sometimes people are confused. What alkali have nitrate? Oh la, I don't know lah. I'm confused. No. Use this thing here. Use this thing. Just combine. Okay, just combine. So this is technically the alkali lah, right? Alkali and acid lah. But does the order matter? No lah, because 1 plus 2 is the same as 2 plus 1 lah, right? Both of them are equal to 3 lah, right? So that's why the order doesn't matter lah, right? As long as you add both of them. So that is acid plus alkali. What will produce is salt. We have the salt already, right? And also H2O water. So H2O. Now you have to balance it. Of course, you don't need to balance it because it's not a calculation, but it's better to balance it just to show that you are doing properly. So it is balanced. This is balanced. Good lah. It's already balanced. So now you know that one. Now use diagram method. So this is titration. Titration have to involve a burette. Okay, a burette. I don't know how to draw. Something like that, right? Something like that. Okay, and then there's a pin there. Nice. Okay, nice. And then you have to know how to draw the thing here to hold it. Okay, this is like this. And then this one, okay. This one, and then there's a conical flask. Okay, Okay. My drawing very bad. My drawing very bad. But the first step, right? You have to put something inside both of these. Okay. So what do we have to put inside? What is the top one you have to put with? Don't forget, the top one have to be what? Acid or alkali? Can someone answer me? Yes, acid. Why? Okay. Here's the question. Is this also a question? Yeah. I remember seeing this question in SPM. I don't know whether it's true or maybe I'm crazy, but I remember one of them asking lah, right? Why the acid has to be on top? First of all, we have to use indicator, right? Right. So indicator that we're going to use is phenolphthalein. Okay, phenolphthalein. Very simple. Okay, phenolphthalein. We're not going to use metal orange. We're not going to use phenolphthalein. What is the condition you have to be? There's three conditions, right? Condition. First is acid, right? Second is neutral, right? And also alkali, right? So when it's alkali is pink, when it's neutral and acid is colorless. Okay, colorless. So if you were to put the indicator inside here, right? Uh-huh. It's gonna be colorless, lah, right? Colorless. Uh-huh. But then if you were to drop it into the alkali, right? And then once it reach neutral, right? So colorless, uh-huh. And then become colorless. That is all useless. So that's why we have to put the indicator in the bottom. And that's why we have to put the alkali in the bottom. Uh-huh. Alkali in the bottom. But I'm not sure of this, right? But you can also do the opposite. Meaning no, I was about to say no, sorry. You cannot. I was about to say you can put alkali and then you put the phenolphthalein there. But no. Don't do that. Don't do that. Don't do that. But common sense, lah, right? Use acid on the top. Okay? Use acid on the top. Common sense. So once you do that, right, you will know how many of the acid that we're gonna use. What is the acid we go use? We use HNO3, right? We use HNO3, right? So after you put it all right, it will be like around here. The level of the water will be there, right? So you have to repeat again. The answer here is yes. Why? We have to ask ourselves, right? Okay, the solution down here, right? It become pink, right? It become colorless because why? It neutralized. So this one is what? Sorry, NaOH, right? Yeah, on NaOH. So this one is already produced the salt that we want. But is the salt that we want the one that we can use? No, because why? There's indicator. Inside here, there's indicator. So that's why we gonna do it again. We're gonna do it again. Okay. I'm just gonna copy this. I'm too lazy. There you go. Now we're gonna do it again, but this time without the indicator. Without the indicator. Very simple, lah, right? Then we're gonna find that uh we get the salt. And what is the salt with? Remember, if you add both of these, right, you're gonna get NaNO3, right? NaNO3 and also water. Do we want water? No. So what process are we gonna go through? Crystallization. Okay, crystallization. So how do we do that? Of course, you're gonna put it in like petrifying this. I don't know, something this, right? Something this. Okay, you're gonna put it inside here, right? And then you're gonna hit it slowly. Okay, hit slowly. The keyword here is slowly. If you don't mention slowly, I don't know whether they will accept your answer or not. Okay, and then the last part you will have to get. You will get like a crystal. Okay, a crystal. So that is you have to cool it down. Okay, you have to cool it down so that it becomes solid. So and then you have to ask: is this clean? Is it solid? Is it dry? So the only thing that it is not is clean and also dry. So what do you have to do? Of course, you have to filter it. Okay, you have to filter. Sorry, my drawing is very bad, but you have to filter by how? By using this thing here. I don't know what it's called. I forgot. But you have to drop it one by one. All right. So and then you're gonna get like some water on the bottom, the leftover water. And then you have to make sure it's dry. So how do you do it? You have to put it between two filter paper. This is filter paper, by the way. And then you have to pat it. Okay, pat it, and ta-da, you finish. Of course, petri dish, coffee filter. I don't know that. So maybe it's petri dish, but it's not coffee filter. So by the way, you're filtering to a filter paper as well. You are using two filter paper. No, three filter paper. Look, all of these are filter paper. I don't know why they're using so much filter paper. Anyway, now this is of course not the final answer lah. Why? Because we cannot answer like this lah, right? We have to write in a proper method lah, right? Proper way. So how do we write it? So the proper way of writing, right? First of all, you have to measure. Okay, you have to measure, and then you have to okay, imagine lah. You have to imagine that you are a scientist, right? And you want to write a recipe book for someone who do not know how to cook. So you have to explain a lot of things to them. Okay, so you have to measure and pour what you have to pour these two, right? These two here, right? These two here. But you have to mention the molarity and also the volume. So the volume you can use anything from 100 to 500. I'm just going to use 100 centimeter cube of now the molarity or the concentration. Concentration, I prefer if you use 0.1 mole decimeter cube. Okay, and pour this one of what? Of what? Of this thing lah. This thing here. You can either use alkali or acid because you have to write it 2 times. Like you cannot write measure and pour 100 centimeter cube of 0.1 mole decimeter cube of NaOH and HNO3. You know, you have to do 2 times. So you have to measure blah 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 and then also measure blah blah blah. Okay. So sodium hydroxide. And you have to mention sodium hydroxide. You cannot, I mean, you can do like this, right? But it's not recommended, right? So I'm just going to do that one because I'm going to save time. NaOH solution. Okay. And then you have to pour them at what? You have to pour them where? This one here, look, right? Where is it? It's at the conical flask. Okay. Okay, I just said pour here, right? So no need to lah. Just yeah. And pour into the conical flask. This is the part like in school, right? In school, they always teach you the sentence method first. They're not gonna teach you the diagram method first. Why? I don't know. It's so dumb, right? It's super easy to do this once you understand the thing. And then of course lah, you have to mention you have to describe this thing here. The first few steps, right, in writing this one, I actually lah, is you have to mention what you do. Okay. What you do first of all. Okay. Now, what you have to do? Of course lah, you're adding an indicator lah, right? So add indicator. Indicator. Phenolphthalein. You have to know how to spell phenolphthalein. Okay, you have to add indicator phenolphthalein. Okay, and then you have to pour 0.1 mole. I don't think I need to explain any of this lah. I'm just writing again lah, right? So what we are pouring again? This thing lah, right? Just now we did this. Now we have to do this. Where? Into the burette lah, right? So burette, into HNO3. Of course, you cannot write that one lah. You can actually, I don't know lah. But it's better to write the full name. Solution into the burette. Okay. So now the fourth one, the thing that we have to describe now is this thing here, right? We have to do it again, alright? So now this one you have to understand lah why it happened, right? So why we do it again, actually? Why we do it again? Because right, we don't want the indicator, right? So we will do this until we find the amount of volume that we need for the acid to neutralize this one, alright? So we'll actually stop, right? Stop. Stop until the indicator change to colorless. Of course lah, right? We are describing what happened. Just describe lah. Just describe lah the best you can lah, right? Some of these are necessary. For example, you have to mention the volume and the molarity, and you have to mention the phenolphthalein. But and also this one, right? And this one also you have to mention. But sometimes people forgot lah, right? Into colorless. Okay. Now you have to repeat again. Repeat after what? After calculating how much acid we need. Okay. because we need a amount of acid lah, right, to neutralize that one, right? We don't need the whole acid lah, right? That's why, right, this HNO3 solution lah, right, if you look here, right, this HNO3 solution that I wrote here, I didn't write the volume. You know why? Because we're just gonna use a certain amount of volume first to determine how much volume we need. Okay, that's why we don't write the amount of volume, right? So we have to repeat after calculating how much acid we need. Okay, my handwriting is getting worse. So number 6. Okay, this is the easy part lah, right? Now we have to heat the salt mixture. So we have to heat the salt. We have to heat the salt solution. Okay, slowly. The keyword here is slowly. Don't forget slowly. Okay, and then what we have to do? Just look here. We have to cool down. So we have to cool down the mixed salt. Cool down the salt. Okay. And okay, just now I explained why you have to do it slowly, lah, right? But you also have to mention until it is saturated. Saturated meaning concentrated. Okay, you understand that one? Very simple, lah, right? So you have to heat it very slowly so that all of these things here, right, can combine and produce very saturated salt. Okay, that's what you wanted. Okay, cool down the salt. Now the next part, you have to filter the salt. Of course, lah, right? We don't want any impurities, right? We have to clean it. Okay, and then you have to what? Pat it. Okay, dry. You have to use the keyword here. Dry the salt between 2 pieces of filter paper. Filter paper. Ta-da! Very simple actually, right? So understand? And ta-da! You already get 8 marks.